Hey guys, how you doing today? We're going to talk about the product rule. It is a pretty useful tool in calculus. Now the product rule, it's pretty simple to understand and it's actually very useful. So now what if we set the derivative of the following function, 2x times x to the second power. Now how much is this? Now of course you could just simply cross or just multiply the two factors that you have. But I'm just trying to show you what the product rule is and how it actually works. Now, the product rule, first of all, something that you need to know is that you're going to use it every time that you have two variables or two terms in which you see an x being multiplied by each other. So for example, if we have 3 times x squared, in this case you wouldn't use the product rule because you only have one variable and you're just, well, technically this is x times x, but if you see it as 3 times x squared, well, 3 is not a variable. It's just a constant and it has no input, or, well, it's not going to take any x input. So, well, you're not going to use the product rule, although it would work if you used it, but there's no need to. Now, if you said, for example, x times x to the third power, now this is different because you have an input, you have x, which is a variable, multiplied another variable, which is x cubed. So now, well, let me show you what the actual rule is. So now, what you want to do in this case is just simply, you're going to take the derivative of the first factor that you see. Now, how much is the derivative of 2x? That is just simply going to be 2. And then you're going to multiply by the factor that you have and just leave it as it is, okay? You're just going to multiply just by how you see it. So this is x squared. Well, you take the derivative of the first thing that you see and then multiply by the second one and don't do anything to it, okay? Don't take the derivative just yet. So you make this multiplication and then you're going to add, and what you're going to add is what you did before in this case, but the other way around. So you're going to leave this term the same and you're going to multiply this term, leaving it the same thing or leaving it as it comes, times the derivative of the other term that you did not differentiate in the previous term, okay? So we did not differentiate x squared in this case. Now we need to differentiate x squared now because we are not differentiating 2x. So now this is just simply going to be times 2x. Now this is just simply going to give us 2x squared plus 4x squared. This is just 6x squared, okay? So this is how much we get. Now, if you want to see it in a more definition sort of way, well, something you could do, or, well, the actual definition of this is just simply if you have the derivative with respect to x for the functions, because this, you could technically say you're multiplying two functions. 2x is a function and x squared is also a function. So if you have u as a function and v as a function too, okay, I'm just going to say u and v are functions, so you remember. So you have functions. Now the derivative of this is going to be, remember, the derivative of the first thing that you see times the derivative of the second factor that you see, but don't do anything to it, okay? So u prime times v, don't do anything to v, plus, now you switch it. So if you took the derivative of u, now you're going to take the derivative of v. So you have v prime times what you did not what you differentiated in the previous term. So we differentiated u, so we're gonna have u as a multiplying v prime, okay? This is what we did up here, and this is basically a rule. Grab the first one, then just take the derivative and multiply by the second one, plus the derivative of the second one times the first one, okay? That is basically the product rule. It is a very useful rule. And now let's do some more examples of, just applying this rule, okay? So let's find the derivative of this function. What is the derivative with respect to x of x minus 5 and x squared times x cubed plus 1, okay? Now in this case you could clearly FOIL, but let's use the product rule, which is actually a lot faster. So we know we're going to take the derivative of the first one. Constant goes to 0, so you get 2x times the same factor that you have in the second place, plus the derivative of the second factor. So in this case, you would have 3x squared, the constant goes to 0, times your first factor, and don't do anything to it. x squared minus 5. Now, in this case, what you can do is you can just simply FOIL, or well, technically not FOIL, but just simply distribute. So you would get 2x to the fourth power plus 2x plus 3x to the fourth power minus 15x squared. Minus 15x squared. And now this is just simply going to give us 5x to the fourth power. Yeah, we cannot, those are unlike terms, so we have 15x squared plus minus 15x squared plus 2x. This is the derivative that we are looking for this product right there. Let's do another problem. What is the derivative of the function square root x times x minus 1? Now, once again, you could distribute, but we're going to use the product rule. So, derivative of the first one, we know in this case that is just the derivative of x to the 1/2. And we know that it's just simply going to be 1 over 2 square root x. Okay, this is something you can memorize, or if you just want to go through the algebra, just do it. But just for the sake of the space, I'm just going to place it in there. We know how much this is. And now the derivative of this times the term that we have, the second term that we have, don't do anything to it, plus now the derivative of the second term times your initial term, or your first term. So this would be just simply 1. So you have 1 times your initial term, that's just going to give you square root x. Now this is just simply going to be equal to x minus 1 over 2 square root x plus square root x. This is your derivative for, the derivative for this function right there.